Welcome back to Gruber Motor Company. I'm Pete Gruber.
I'm Mark Schaffner. Good morning.
And this is the Gruber Morning Show. We've got a lot to cover with you today. And first thing is the image behind us. It occurred to me this morning that with as cold as it is here in Phoenix right now, it is after all going into February, it would be nice to post a picture of the heat in Phoenix. And I assure you that when July rolls back around, I won't be saying that. But right now, this looks like a welcome change. This was taken by Pinnacle Peak, north of Scottsdale, Arizona. And that's typically what our countryside looks like here.
Yeah, that's a beautiful view of the Sonoran Desert. And based on the blooms, that looks like it's probably a late spring picture. It's probably also about 110 up there.
Right, right. And despite that, people will hike. They start early, of course, but you see them with their water bottles, ready to hydrate, and it's fun walking or hiking in through these smaller mountains.
Watch out for those rattlesnakes.
That's true, yes, yeah. It's not uncommon to see some of the wildlife here in Arizona, tarantulas, rattlesnakes, coatimundi, scorpions, yeah.
Yeah.
It sounds like Jesse doesn't like hiking.
Yeah,
He's scaring us.
like it, especially in the spring when those rattlesnakes are just first coming out.
So we've got an article here that I wanted to share with you.
Hold on, Pete. We gotta give the announcement first.
Okay.
Let me do that real quick. So, for everybody watching, obviously this show is not live. We'll be back live next Tuesday. For our people on TikTok, this is going to be one episode that you guys don't get. So we hope that you have made it here. We'll be doing a live announcement to bring people over here as well. Again, this will still be on Spotify the day after we air this Thursday morning.
Thank you, Jesse. So one of the first articles I wanted to share with you was an interview that a magazine did, MIT Technology Review, with J.B. Strobel. JB was the chief technology officer at Tesla for 14 years. He was Elon's right-hand man, and he was also extraordinarily knowledgeable on all early things Tesla, and we at times are able to tap into that wealth of information and knowledge to help keep the first generation Tesla on the road, the Tesla Roadster. JB, by the way, has two of them, and he was telling me last year that one of his Roadsters has the first Tesla Roadster battery pack in it, and it was still functioning at that time.
Wow.
15 years later or more, yeah.
And aren't we working on, or haven't we worked on, the Tesla Roadster that JB's father has?
It's still in our shop, yes. Yeah, JB's dad, and his name is Jeff, so there's another J in there. And it's a unique Roadster. It lives off an island on Lake Michigan, and it came to us bricked about 4 months ago or so. Bricked meaning that the battery went dead. We've recovered it. It's running again, which actually surprised Jeff, and we're now going to do some upgrades for the car and possibly even a paint job or a wrap.
Oh, that would be wonderful. That'll make that car look like brand new, and it'll be good to see that one back on the road.
Mm-hmm. So JB was the founder. He left Tesla, by the way, and he talks in this article about why he decided to leave Tesla to strike out in a different direction. He says, and I quote, "Certainly, Tesla was an amazing adventure, but as it was succeeding, I think it was becoming more obvious that battery scaling would present the need to get so many more raw materials, components, and batteries themselves. And that was going to be a large looming bottleneck challenge for the whole industry, even back then. And I think it's even more clear today." So he says the idea was pretty unconventional at the time, but why did you leave this glamorous, exciting, high-performance car company to go work on garbage? And what he means by that is he founded a company called Redwood Materials, which recycles EV-type components, especially batteries. And he says, I think entrepreneurship involves being a little bit contrarian, and I think to really make meaningful innovation, it's often just not very conventional. So what JB did was He started a company, Redwood Materials, and its sole function in life is to take expired lithium-ion or battery packs in general from a variety of sources, not just EVs, power tools. Virtually anything has a lithium-ion battery in it these days. And they are successfully recycling batteries, which of course is a huge concern because the old traditional lead-acid batteries, when thrown in landfills, are very hostile to the environment. You have sulfuric acid, you've got lead, and recycling is a far more responsible, planet-friendly method of taking care of the recycling. He says, and if we don't electrify everything, I think our climate goals are completely sunk. But at the same time, it's a phenomenal amount of batteries, and he felt that they really need to figure out a robust solution at the end of life. He continues, he says, I think this entire new sustainable economy as we're envisioning it, with everything electrified, simply cannot work unless you have a closed loop for the raw materials. And there aren't enough new raw materials to keep building and throwing them away. That would be fundamentally impossible. So this is where recycling then becomes a compelling reason to move into something like that. He also adds, though, it's not easy. He says, blazing the trail, as you might say, it's more complicated than I think many people appreciate. There's a whole ton of chemistry, chemical engineering, and production engineering that has to happen to make and refine the components that go into a battery. And it's not just sorting or garbage management problems. So he says that as an engineer, this is the fun part of it, is getting to innovate. And by the way, there's a story about JB, which his mom shared with another, I think it was another EV article or EV magazine. Mm-hmm. And she mentioned that even as a child, JB was very much engineering minded. And there was some story about a golf cart that he wanted to repair and make operational. And it was really his first introduction to electric vehicles. Now remember, a golf cart is an EV, it just runs on DC. It's not quite as elaborate as the current electric vehicles. But she could see fairly early on that JB had an engineering mind, and that his commitment to this golf cart was way beyond what most kids would devote to something like that. So he says it's not something that is intuitive as to what a high level of reusability of the metals inside the battery have. All those materials that we put into the battery and into an EV don't go anywhere, they're still there. They don't get degraded and they don't get compromised. 99% of those metals, and perhaps more, can be reused again and again and again, literally hundreds, if not thousands of times. So we're truly looking at a closed loop system here. Once that EV battery expires, it can be completely recycled, and we don't have to go out and find new mines and transport across the world to create new batteries once this closed loop system is in place.
You know, that's it's one of those times when you ask yourself, why didn't I think of that before? Mm-hmm. People have asked questions I've seen over the years with electric vehicles. Oh, this is great, but what about the lithium? What about the cobalt? What happens to these batteries when they end up getting thrown away? You know, I hear the stories about people that take and drop their little DeWalt lithium-ion battery into the trash can, and then 4 days later the trash can's on fire because the lithium caught on fire. And why not recycle?
Sure. You know, one of the things that we did 30 years ago was when the UPS equipment, uninterruptible power systems, which is the world that we came from, critical power equipment, eventually went to scalable UPSs with plug-in battery modules. Mm-hmm. At that time, there was no recycling for those battery modules, and we were suspecting that some of them ended up in landfills. And of course, you got lead and sulfuric acid and plastic and all that. We were the first ones, really, over 30 years ago, to pioneer the recycling of those batteries not just to render it back into base materials, but to put new batteries inside the cases, the scalable cases, the Symetra, for example, scalable batteries, the Cybat battery. And we found that to be very advantageous for a number of reasons. It prevented them from ever ending up in a landfill. And it gave a customer that had a UPS an alternative to purchasing a brand new battery pack. What we ended up doing was we would simply replace the 12-7 batteries inside this battery pack, and there were 10 of them, still are in fact. And the other advantage was because we do such high volume, the customer ended up with a fresh battery. Oftentimes, when these batteries were being manufactured, they would go into inventory and sit on a shelf somewhere aging. And batteries are kind of like vegetables. You don't want them to age. You want them to be fresh so that chef can make a wonderful recipe. What we were able to do was replace these batteries and then have a disposal company responsibly recycle the old batteries. So it's nothing new, at least in a critical power world, but it's now being applied to EVs. And as JB says, there are auto recycling yards that recapture some of the components of conventional cars, but there is nothing that approaches the 99% plus recyclability rate that JB Strobel predicts. There are companies, or there are people running around who shriek about how EV owners are just driving their cars into the lake when the battery dies, and that soon our landfills will be overflowing with toxic effluent leaking from the mountains of discarded batteries. Those people are all about making a political statement, one that is completely divorced from reality. So then we go on, and it goes on, this article talks about the looming climate crisis. And it says that JB is clearly focused on the challenges of an overheating climate and feels the need to move forward with electrifying everything as soon as possible. He says, I generally don't think that we're going fast enough. I don't think anyone is. And he says, you know, you have to have a sense of paranoia and urgency and almost, not exactly, panic. But I guess it really derives from a deep feeling that he does not believe that we're appropriately internalizing how bad climate change is going to be. So some anxiety and fear about that definitely would motivate some changes in the right direction. He says that it's going to take us decades to completely get a handle on this, but then he adds, and yet politicians in Wyoming and Virginia are looking to score political points by mocking the transition to electric vehicles, little realizing that this isn't about politics, it's about survival of the human species. So here again, we're talking about climate change, we're talking about the negative effects of allowing this to continue, unchecked.
And there's I've seen a little bit of a movement coming out on the left, on the progressive side, the environmentalist side, saying electric vehicles are not all that. You're still producing greenhouse gases in order to produce an electric vehicle. You have to drive an electric vehicle 100,000 miles, I've seen some articles say, before you're actually becoming more efficient than driving something that's similar to gas. They seem to miss the point. Because the point is, you can recycle these batteries. It's going to use a lot less energy to recycle these batteries than it will be to mine the batteries out of the earth. And they're making that assumption that once a battery is mined, once it's used, it's depleted, it's gone, you have to throw it away.
Right.
And that's just a false assumption.
Which is the beauty of this type of battery technology, is that it's truly a closed loop system, and it's almost 100% recyclable.
Yeah, that is really impressive. I certainly hope to see JB Strobel and his company grow quickly and be able to get a lot of business from this.
Looks like we've got a question from, oh, there we go. It's jumping around a bit here.
Let me just get to the top for you.
Okay. Our team back there is collecting the questions. It looks like TikTok, Bill Wood. The U.S. government needs to demand we start making all electronic components in the U.S.
I think that was probably a reference to what we were talking about in our last podcast about the chip shortage and how so many of the U.S. manufacturers, in cars especially, are dependent upon chips being manufactured in places such as China and other places in Asia. I know that the Biden administration is trying to push toward that. It's not something that can happen overnight. I also know that Taiwan Semiconductor Manufacturing Corporation, or TSMC, is putting $40 billion right here in our backyard in Arizona to build 2 fabrication plants that will help resolve the chip shortage, and so that people can do exactly that. The manufacturers can start buying more of their components right here in the U.S.
Yeah, I don't think many people realize that the large TSMC plant in Taiwan was the major global producer of certain types of chips, and there's a severe vulnerability there. You know, if China decides to do what Russia did, all bets are off what's going to happen to supply chain.
Yeah, all bets are off, most definitely. And when Taiwan went into lockdown because of the COVID virus, man, the shock waves are still rippling some 3 years later.
Pete, one thing that we might look into as well, because I don't know this, is it proprietary to those factories, or is it just the cost of labor? Why is that the only place in the world that they make those things? That would be something good to look into.
It would be. I think it'd be a great video. You know, certainly economics play part in that.
Yeah, I'm not totally sure of that.
Yeah, I can't imagine chips made here in Phoenix are going to be the same price as ones made in Taiwan.
While I can't imagine that, I do know that Apple made a tremendous commitment to buy a lot of the chips for their iPhones from the TSMC plant here in the United States. A lot of these large manufacturers consider the cost of the political instability in the area where manufacturing is taking place. And of course, the United States is considered one of the most politically stable environments in the world.
Mm-hmm. Looks like we got a question from TikTok user with a bunch of numbers after it. Are you coming to California? Well, not anytime soon. We are scaling here locally only at this point in Phoenix, Arizona for Gruber Motor Company. And it's very difficult to scale this type of operation because of lack of manpower, which is, of course, the same thing that many other companies are going to run into. The people skilled in working on EVs are in very short supply.
Chris Denman from TikTok also asked the question, raw materials for lithium batteries, such as cobalt and etc., are rare and at a premium. What's the future like?
Well, recycling sounds like the best place to do that, because all of these minerals and these metals that Chris mentioned are recyclable.
One other thing. Yeah, sorry, go ahead.
Yeah, with 100% recycling capability, it looks like we're less dependent on mining and bringing them in from other parts of the world. You know, lithium, for example, the largest mine is what, in Bolivia?
Yeah.
That's a long ways from the U.S. where the batteries are being made. And then you talk about, you know, climate change, to transport. You know, we've got a lot of internal combustion engine transport activity to get that raw material where it's being used in the factories. So that's another reason that companies like Redwood Materials now building a second plant closer to production facilities where batteries are used really cleans up a lot of things in supply chain and in global warming.
I could see that really becoming a game changer as time goes on.
Mm-hmm.
Jesse, you had something for us.
Yeah, I was just going to say the future, in my opinion, the long-term future is going to be nuclear fusion or graphene or a combination of those. I don't think lithium and the materials are going to matter for very long.
And we love fusion, by the way. It's just we're waiting to get some production capacity going with that. And Jesse is very much a proponent of fusion.
You know, I think Jesse is probably right. If you look back, it's 2023 right now. Go back to 2003. The only vehicle that existed that had any kind of battery power, as far as I know, was probably the Toyota Prius. And they had a very small lithium-ion battery, and lithium was considered a really new and novel component. Well, now they're talking about potassium, lithium iron. There's a new lithium iron plant going in Tucson. They're talking about sodium-ion batteries. In fact, a little bit later, we're even going to talk about some solid state technologies that are coming to the forefront. So I think the lithium ion might have a shorter life than we realize.
Yeah. The Priuses, I believe, had metal hydride. In the early days of Gruber Motor Company, we used to repair Priuses, and the only option for a customer that owned one that had a bad battery or deemed as a bad battery was a complete battery replacement, which at the time was about $5,500 to $6,000. And they were repairable. They were pouch batteries, pouch cells, and if you found the bad pouch, you could replace it and the car would continue to function.
Oh, that is fascinating. Yes, I remember now the nickel metal hydride. That's right.
Yeah. So it looks like a question pulled from TikTok. KBUD1, missing battery in a lower KWH Model S. Most likely that's going to be a 40 or 60 kW. Can you add the missing batteries? What this audience member is asking about is, in order to reduce the kW size in the Model S's, there were actually modules that were not fully populated with cells. And that's one of the ways they reduced the kW. And in an 85, then you had a full complement of cells, 85 kW. It's a two-part answer. Yes, it is possible to repopulate those cells, but the logistics are, in order to add any cells to this module, you would have to disconnect bonding plates, which are connected with an ultrasonic welder and fine fusible link wires. So you would have to strip all of those off, open up basically the module, slip in a battery, and cement it into place, and then use an ultrasonic welder to rebond all of the connections, front and top plates. There are two of them. Not to mention the fact that in order to get to that module, you would have to drop a 1,200-pound pack out of the car, peel it open, peel the top open, and then get the module out. It's just not economically feasible to do all that work to raise the kW 10 or 15 kW. It's much less expensive to just simply get a larger battery.
Well, wouldn't you also even have the situation with lithium-ion batteries that I know exists with lead-acid batteries? You don't mix old and new batteries.
Right.
Because the older battery is going to have a higher resistance level than the new battery would have. And as a result, that mismatch causes both batteries to discharge more quickly and actually wear out more quickly.
Sure. There's that, and then there's also the redeployment of software to convince the car that it has a new battery pack now that has a higher capacity. So yeah, the logistics and the cost involved just don't make it economically feasible, but the basic answer is it could be done, just not worth it.
Sure.
Okay, you guys want to move on to a news article? We'll save some of these questions for later.
Sure. So Elon Musk says that a Chinese automaker will likely be second to Tesla. And he adds, they work the smartest, meaning the Chinese manufacturers. He says that the EV manufacturers in China are winning in China right now. And he identifies BYD as being one of the biggest rivals that they have in China. He also adds, we have a lot of respect for the car companies in China. They are the most competitive in the world, and they work the hardest, and they work the smartest. And this was all stated during the last Tesla earnings call last week, actually.
Now, I haven't heard a lot about BYD batteries. I know you and I were talking a little bit earlier, and you said something about the BYD people being the ones that might allow somebody to drive in and do a quick battery swap instead of a recharge. Can you tell me more about that?
Yeah, I actually watched a video by Kyle Connor. He has a YouTube channel. What's the name of it, guys? Escapes me off the top of my head.
Out of spec? Yeah,
Out of spec motoring.
Yeah.
Out of spec motoring, yeah. Very knowledgeable guy, by the way, EV enthusiast. But anyway, he was in Norway, and he was driving a BYD. And he decided to try out the battery swapping facility in Norway for the BYD car. And I remember him driving, it was wintertime, ice everywhere, snow everywhere, and it kind of looked like a gas station with this large, almost like a car wash type attachment. They drove the car into place, and the floor of the car opened up. There were plates that kind of hid what was going on underneath, but the young lady that was with Kyle actually was able to get some video of what was going on as this process took place. I highly recommend you watch this video. Again, Out of Spec Motoring, Kyle Connor, and it was the BYD battery swap taking place. But as Kyle pointed out, he said, you know, there were no cars queued up in line waiting for the swap, and it took about 10 minutes. What if you had 3 or 4 cars sitting there waiting to queue? There were superchargers right next to the building. Would it not be faster to just simply plug in and get a supercharge and be out of there in 20 minutes rather than wait 45 minutes to an hour to get a battery swap? The other thing that I was looking at was it looked like an enormous engineering challenge to do this type of a swap. You've got a battery that weighs 1,000 pounds. You can't tell what kind of environment this is going to take place in. Did the car have chunks of ice underneath it, as they normally do when you're driving in cold weather? What if that dropped on the battery or on the platform that was trying to open up to grab the battery? And it just did not look like an efficient way to do it, although it was an engineering marvel, the fact that they were able to build this, and it did, by the way, swap the battery in the car that Kyle was driving there in Norway.
You know, I could see that being a very intriguing and interesting option. On the good side, you'll never have a bad battery. I mean, this is the EV battery equivalent of taking a propane tank down to Home Depot and swapping it out for a brand new propane tank that's full. You're always with a new battery. But on the other hand, that 10 minutes, that's just too long. If it could be 2 minutes, that would be something. Because now you're talking about, okay, I'm going to go in and drive up, and 3 minutes later, I'm going to be out of here. I'm getting a refreshed battery faster than I could fill up with gas.
Sure.
But I think the technologies that are coming up for fast charging are going to be such that you'll be able to simply go to your station, plug in your car, and in 5 minutes be done. And that would render something like this just completely obsolete.
Sure. And then there are other ethical issues. If your battery is starting to die on you, what would you do then? Drive it down to one of these charging stations and get yourself a replacement battery? You know, and how would the manufacturers control that? Because it's definitely a motivation or an incentive. So yeah, although it was a great idea at one point in time, a lot of companies have abandoned that. I remember Elon at one point was up on stage during an earnings call. This was like 3 years ago or so. And they were pretty excited about demonstrating that you could actually do a battery swap within 90 seconds. And up on stage, a Model S comes driving out. There was a false floor underneath the Model S when it finally stopped. And they must have had the equivalent of an F1 team down below, because within 90 seconds, there literally was another battery inside this car, and then it drove off. Well, I don't think that they're going to have F1 teams at these battery swapping stations, so 10 minutes looks like about a reasonable time for that.
Well, that's actually another issue too. If they design these batteries to be swappable that quickly, doesn't that leave you open to theft pretty easily as well, right? Somebody could just snag your battery. And then also with inductive coupling, I mean, in the future, there's not going to be any need to swap batteries.
Oh my God, you just opened up, or you gave them an idea. Remember, we have this current problem with catalytic converter theft because of platinum, right? Well, that battery, like you said, is worth $1,000, well, more than $1,000 actually,
it's 20,
probably.
20 grand, right?
Yeah,
for a Tesla
yeah,
battery.
there you go. Yeah, if they make it too easy for them. But can you imagine, right now when they steal your catalytic converter, they bring a jack, a Sawzall, and they crawl underneath the car with a creeper and they take out something that weighs maybe 25, 30 pounds. How would you handle a 1,000-pound battery pack?
I don't know, but it's not to say that they wouldn't try.
Yeah, good point. All right, it looks like we've got a question from Gasp 421. The Model 3 that was in our shop with a cool paint, what was wrong with it? You know, I don't live over in GMC. My office is actually in this building upstairs. So I never did get the backstory on why it was there, but most likely for something that's in warranty, it was an aftermarket modification of some type. And that particular car that you're referring to was actually a wrapped car. It was not painted. But yeah, it was stunning. It was pretty spectacular. It just amazes me what people will do to upgrade, some of these Teslas.
But it could be any reason, right? That thing's off warranty. It could have been crashed, and now it's a salvage title, or
Could be salvage,
something
yeah.
like that.
It may have been tire work, suspension, yeah, who knows?
I think one of the most surprising things that I've learned about these cars over the last couple of years is that these incredible paint jobs that look stunning and just are like, wow, how did you do that? They're not paint jobs at all. They're a PPF wrap on these cars. They look like they're beautiful paint jobs, but just like paint, they'll wear out over time too.
Yeah. It's at a point now where wraps like that have exceeded the capabilities of paint. There's certain things that you can do with those that you can't do. Like that iridescent color where it changes colors based on the type of light. Yeah, there isn't a paint yet that is available to, or to do things like that. All right, so Yabot has a question. He says, how do you take the resistive batteries out, snip the fuse, or physically remove? What he's referring to there is, in an electric vehicle, a multi-cell design, meaning that it's got thousands of 18650 cells, cylindrical cells connected in series and parallel, which is what the majority of Teslas are, all of Teslas actually. One bad cell in a Tesla Model S, for example, out of 7,104, will eventually kill the car, and sometimes rapidly, because the battery safety management system will only allow a charge to the weakest cell in that car, or the weakest brick. And that's for safety reasons. If you overcharge a resistive lithium-ion cell, it ignites all its neighbors, and the next thing you know, you have a massive fire that the fire department has a difficult time putting out. So the way that we, first of all, you have to find the resistive cell, and it's not easy because in a brick, these cells are connected in parallel. And when you have a parallel connection, one bad cell makes the rest look identical to that resistive cell. It brings the rest of the cells down. So that's the first level of advanced skill, is being able to find that needle in a haystack within that cluster of parallel cells. Once we've identified it, we then take and simply snip the fusible link wire or the bonding wire. We leave the meter on the cell, and we then confirm that that was the resistive cell, because if it was, it will drop like a rock. The voltage will just decrease rapidly. It was the other cells that were holding up the voltage. If it doesn't drop, which we haven't had happen, by the way, you know you've got the wrong cell, because a battery charged is capable of maintaining the voltage that it was charged to without a load. So that's how we do it. We just simply snip it out. Many people have asked, well, why don't you replace it? Well, it's destructive. You've got a cooling jacket that runs through there. You have bonding plates that need to come off, and you have to redo all of the fusible link connections with an ultrasonic welder. But the real reason we don't do it is the cars never realize that 1 out of 7,000 cells went MIA. It doesn't care. It doesn't notice it.
5 or 10.
Or even 5 or 10, exactly, yes.
Right. And speaking about those cells, there's a lot of testing that's going on with new battery technologies too. These lithium-ion cells, you just mentioned, it has the coolant, and most lithium-ion batteries today in cars are basically a lithium with an electrolytic liquid coolant. I'm sorry, not coolant.
A glycol.
Yeah, electrical glycol. And then you have the cathode and the anode, the plus and minus on the batteries. But that liquid is what keeps the battery from
Oh, sorry, you're talking about the chemistry inside the cell.
Yeah, the chemistry inside the cell.
Not the cooling, yeah, because that would be glycol. Inside, there's an electrolyte.
Yeah, the electrolyte within the battery that keeps that positive and negative apart. BMW is getting ready to actually put a car on the road that works with a solid-state battery and not the lithium-ion that we're used to seeing. Mm-hmm. The Solid Power's new battery cells are being readied for prototype cars. that really piqued my curiosity, because what's the difference between today's lithium-ion battery and these new solid-state batteries that are out there? So I did a little bit of looking. If you guys could go ahead and put up the graphic of the solid-state battery. And this came from Samsung itself. When they
Now this is the Versus picture.
yeah, this is the lithium-ion versus solid-state battery. From Samsung, it says a lithium-ion battery is composed of a cathode, an anode, a separator, and electrolyte. So this lithium-ion battery, which is in smartphones, power tools, electric vehicles, it uses a liquid electrolyte solution. Now, on the other hand, a solid-state battery uses a solid electrolyte, like a ceramic, not a liquid. There are a couple of important differences when you look at this particular image. There's that Li plus separator that's kind of tan is your liquid electrolyte. And that separator keeps your cathode and your anode apart with the solution. The solid state is not using that liquid electrolyte solution. It uses a solid electrolyte that plays that role instead. The main thing about these batteries, and you've already mentioned that, and we've already experienced it, is safety. A lithium-ion battery has a risk of battery damage, such as swelling that can be caused by temperature change. It can have leakage, where the electrolyte starts to leak out of the battery. Over time, the charge will degrade because the actual battery chemistry of the lithium ions is changing, and the lithium is growing toward itself inside of that liquid solution, and eventually will short itself out. That's part of what the resistance is in batteries. These solid state batteries do two things that are going to be critically important over time. First, they don't catch fire. They don't heat up when you're charging them in the same way that the liquid electrolyte heats up, and so you can charge them faster. And so the second thing is that they just don't degrade over time. The electrolyte doesn't have, the solid electrolyte is better able to keep the two lithium ion, the cathode and anode, apart from one another because it itself is solid. And it allows these batteries, instead of having the lithium ion charge of maybe 1,000 to 2,000 cycles, it can have hundreds of thousands of cycles without any degradation whatsoever.
So we're talking about less flammability or none, and a longer lifespan for the battery.
Yeah, a longer lifespan, possibly meaning as much as 100 to 200 times or more lifespan than what's in a standard lithium-ion battery today. And so things like the repairs that we're talking about that we do for the lithium-ion batteries and Teslas might become unnecessary someday, because these batteries simply won't degrade. They'll be able to take charges again and again and again and again. In fact, the higher charge rates for super fast charging is one of the things that causes the heat. Heat's what causes the batteries to degrade, because the chemical reactions that are occurring inside the batteries. Stanford researchers found, and it made the press this week as well, that they think they have figured that out.
Really? Okay.
They put a ceramic electrolyte, so it's a solid electrolyte, and they found that it's like a clean room. If you have a particle of dust on a fiber optic cable, you can completely degrade the fiber optic signal over several miles. If you have a single particle of dust in one of these electrolytic batteries, that particle of dust acts almost like sandpaper, and it'll grind down at that ceramic cathode, that ceramic electrolyte, and eventually cause it to fracture, which then causes the lithium to be able to get to either side. One of the things one of our listeners was telling us about, how electricity is always looking for the shortest path. It's always looking for the easiest way. Well, that's what happens there. Once those cracks take place, the lithium the cathode and anode reach each other, you have a battery short, your battery goes bad. And so in Stanford, they're figuring it out. They're figuring out what it's going to take to keep these batteries going, to accept faster charges, and to not be flammable.
You know, with the incredible demand for these types of batteries or DC storage in general for EVs, there are a lot of companies now pouring enormous amounts of R&D capital into these kinds of technologies. So we can expect a much improved method of DC storage in the future.
Yeah, and you know, getting back to BMW to kind of close out this article, they did actually say a time frame for starting to do their testing. They're beginning to do their R&D testing now, here in 2023, and they think that they're going to have a vehicle on the road for test purposes by the end of 2025. So that's going to be something that happens within a couple of years.
Amazing. Really amazing.
And we are at 45 minutes if you guys want to take a couple more questions.
Okay. All right, Eric Jenkins. He's asking a question about a video where we're showing balancing a battery in an EV. Can an equalizing charge be done with the battery in place? Oh, very much so. One of the common repairs that we do is after we find a bad brick, a resistive cell, we then have to make sure that we bring that brick voltage to the same level as the other bricks in the car, because again, battery safety management looks for a delta or a difference between voltages, and it will only allow a charge to that lowest brick. You're going to get your maximum charge, state of charge, if all of the bricks, all of the cells in other words, in that pack are at the precise same level. So we actually have to develop equipment like our 11-point charger, which allows us to put a charge onto every single 11 of the sheets in a Tesla Roadster to bring them up to the same level. Or we even do that with the bricks individually. There are 99 bricks in a Roadster, 11 sheets in a Roadster. And that allows us to then bring that pack, equalize that pack, so that when it goes back up in the car, it's going to see a maximum charge. If you don't do that, there is a bleeding mechanism or an equalizing mechanism in a Tesla Roadster or in a Model S, where it will eventually equalize all of the bricks. However, that takes a long time. So we try to jumpstart that and make sure that we start off with as much range as possible. Question from Panopticon. Are you selling one? And he's talking about Roadsters. We have a Roadster matchmaking site on our website, which has been in operation for over 2 years now. And it has become the place that people trade Roadsters. We have, on any given point in time, 30 or so plus Roadsters for sale. And the beauty of this is we do not charge for the service. Our function is to unite the sellers with the buyers and provide tech support in the process. There are two things that I just mentioned that auction houses can't do. They can't do it for free. They're for-profit businesses. And they do not know how to provide any tech support on a Tesla Roadster or EVs for that matter, because they sell all types of cars and they're not EV experts. So if you're interested in any Roadsters, go out. If you're interested in just tire kicking and shopping to see what they're worth or what they look like, it's a great site to visit. We have cars for sale that are listed from all over the world. And again, it's completely free. All you have to do if you're interested in one is email us at ev@gruber.com, and we will release the owner information, and then you take it from there. You deal directly with the owner. All of your price negotiation is with the owner, and we oftentimes can help once the sale is made, in that we offer a free escrow service.
Yes.
Again, completely free, and transport services within the continental United States. We subscribe to Central Dispatch, and we can find transporters for vehicles and get you the best price.
You know, we are truly just that matchmaking service. So we're not selling the cars ourselves. I think that was important that you mentioned that we get people in touch with one another. So if you have a Roadster you're looking to sell, contact us at ev@gruber.com. We would be able to help you get your car onto the site in order to be sold, and we can give you some tips and pointers. If you're looking to buy the car, like you said, you go to the Gruber Motors website, grubermotors.com, and there's the Roadsters for sale. In fact, I think I saw that scrolling on the screen behind us just a moment
Yep,
ago.
we have a live chat on there too. You can chat with us, you can get our
Live
phone
chat,
number,
right.
all that stuff. Yep.
And by the way, I find that the tech support option that we offer is as important to sellers as it is to buyers. The seller oftentimes, what is it worth? What should I sell with it? How do I present it? What are these options in the car? We teach them how to give a CAC value, for example, which is the calculated amp hour capacity, which is the health of the battery. And that's important to a buyer. And then the buyers have a wide range of questions. How do I maintain it? How do I charge it? What options are available? And it has turned out to be one of the best free services that we offer, amongst others, of course.
By all means. Chuck Espinoza Photo asks if we would mind doing a video about the annual maintenance on a Model S.
That will definitely be one of the videos, the tutorial videos. That's going to be an easy one to do. There is a certain amount of maintenance, and it's minimal because it's not an ICE car, that you can do with your Model S. We'll have a tutorial soon. How much, here's a question from user, long numbers afterward, Model S. How much is it to replace that one cell? Well, first of all, we don't replace the cell, we neutralize it. We take it out of circuit. And you have to remember that in order to get to that cell, car goes up in the air. We have to drop a 1,200-pound battery pack. We then have to take the lid off, which, by the way, is technically not reusable, so we end up having to do body work to put it back on the pack. We had talked to Tesla last year about being able to buy lids, which would reduce the cost of the battery service, and they're still working on it. But it's in the range of $4,000 to $6,000 to repair a Tesla Model S battery pack.
And compare that to the $12,000, $13,000 for a reconditioned Model S battery pack from Tesla, or the, what is it, $22,000 to $25,000?
Yeah.
Yeah, $22,000 for a new battery pack, and you're starting to realize that that itself is a great bargain as well.
Mm-hmm. Well, I have another news item for you, and the question posed on Quora. Yeah. Why doesn't Toyota sell EVs in the USA? Well, the fundamental reason is Toyota doesn't have anything to sell. They tried to make one, which was the BZ4X. But they sold so few of them because it quickly developed a bad reputation for a number of reasons. There were recalls. So then you might ask yourself, well, why doesn't at that time, the world's largest car manufacturer make an EV and jump on the bandwagon? Well, now this is opinion, and this is in this particular article. The hypothesis proposed was that Akio Toyoda, who is the CEO of Toyota, and by the way, his name is spelled with a D, Toyota has a T in it, is stubborn, is what they say. He does not want things to change, but the more compelling reason they feel is that Toyota does not have the money to develop can we bring up a chart, by the way? It's the car manufacturers in debt. And what is surprising is that Toyota Motor is the world's most indebted corporation with a net debt of $186 billion. And that's according to London Business News. So it's either, the reason either is Mr. Toyota's stubbornness and or the fact that they really don't have the capital to venture into the EV space, which of course is highly capital intensive because you have so much infrastructure you have to change in order to develop an electric vehicle. Well, the rest of the news is that Akio Toyoda is stepping aside, and there is a new CEO that is going in April 1st of this year. His name is Koji Sato, and he currently serves as president of another division within Toyota Motors. So anyway, if you're looking for a reason why doesn't Toyota, one of the largest manufacturers on the planet, auto manufacturers, why aren't they into EVs? That may change during this new leadership, or this leadership change.
I've seen elsewhere that Toyota has been really the proponent for hydrogen fuel cell cars.
Mm-hmm.
And it seems like they're the only ones out there that are pushing this. They say, oh no, EV is bad, and they poo-poo the whole EV thing. And they say hydrogen fuel is the way to go. Hydrogen fuel cell is the way to go. I don't agree with them.
Which of course runs contrary to what all the other incumbents are currently doing. You know, how many other manufacturers, auto manufacturers, are jumping on the hydrogen bandwagon? As in none, perhaps?
Yeah.
Okay. Got a question from JWolt87. Do you fix batteries on a 2022 Mach-E? When we got really busy with Tesla, and Tesla Roadster most recently, we found that we were no longer able to support the other vehicle brands. When we started, there wasn't that much business for us, so we repaired Ford Fusions at the time. We repaired Priuses and Chevy Bolts. Currently, we are fixated on Tesla. In fact, we're even turning some Tesla Model S customers away because we get so much Roadster business. And we feel that that's important to remain in that sphere because there's so few options for Tesla Roadster owners, and they are only 1,700 or so left, and they're very important in the automotive history.
TRG also has a question about the batteries. When we're talking about the cell failure, he asks, why isn't there redundancy in these expensive batteries?
Well, the technical considerations are, if you were to put a battery management system on all 7,104 cells in a Tesla Model S, you could actually create electronics that would disable or remove that battery from circuit.
Mm-hmm.
But it's not economically feasible to put that much battery management into a battery pack. The good news, though, is that the type of DC storage systems that we have today, lithium-ion, will evolve fairly rapidly as the EV revolution continues. And we will have much better DC storage methods, but for now we have to live with what we have.
Sure, and I know with the experience I've had when we work with the lead-acid batteries with Gruber Power Systems, those batteries will age over time, whether they're in use or not.
Mm-hmm.
And so if you have a redundant battery, then that would imply to me that maybe it's not being used, which would also imply that it's going to age whether it's in use or not. When it comes time to use that redundant cell, you might find that it's not able to be used any longer.
Yeah. And then, of course, if you're talking about a redundant pack, you'd have twice the weight and twice the expense.
By all means. PK asked, in referring to the Roadster cells, aren't the cells in the Roadster battery pack the same batteries that are in cordless drills?
Yes, they are. They may be a slightly lower amp hour rating or the same. It's the 18650 lithium-ion cell has become one of the most commonly used batteries in a variety of devices, from toothbrushes to laptops to tools, alarm systems.
Your favorite one is vape cigarette cells.
Vape cigarette cells, yes, yep.
You know, I even joke with my wife, hey, let's go get 8,000 vape pens and turn it into a car battery.
Yeah, and you could do that, yeah. So yes, it is the same battery, the same type of battery, and of course even lithium-ion is improving, the designs are improving. We then got the 2170 cells. The geometry, by the way, is 1865 actually. It's 18 millimeters wide by 65 millimeters long. 2170, same thing. And the 4680, which is even larger. So yes, I don't think they're going to be using the 4680s in power tools because they have to fit in the handle somehow. You know?
Yeah, that would be awfully big.
You got a soup can down there if you're trying to put that into a cordless drill.
You know, I think we have time for maybe one more question, and then
Sure.
And Oracle had asked the question for us, how do you find that bad battery? Is it software or is it a mechanical process?
It is a electronic measurement process. The software does not identify problems down to the cell level. It identifies problems to the brick level, which is the collection of, in the case of a Roadster, 69 18650 cells connected in parallel. And then there is no mechanical process other than the snipping of the fusible link wire.
Okay, so the software will get us from 7,000 plus cells down to less than 100.
Right.
But once you get less than 100, it's basically taking an ohm meter and testing the cells.
Mm-hmm. And it is a fairly common process. With Roadsters, some of them are going on 14, 15 years now and still running. And what we see, of course, is all of the aberrations or the problems with a resistive cell. Mm-hmm. What really exacerbates a Tesla Roadster battery or damages it is if it gets bricked. And that's typically when the marginal cells become resistive. And often it's just one. If it's extended 6 months or more, then it can be more than one cell. And at some point, it's no longer economically feasible to try to repair a brick Roadster. Then the solution becomes a $30,000 battery replacement by Tesla at one of their service centers.
Now, and on the Roadsters, because they're the older design, there are some systems in that Roadster that are constantly causing drain on the battery, correct?
Correct.
Because I know that we have to, we pull the service plug when a Roadster comes in, and in many cases we'll tell our customers, hey, even before you send it to us, reach under there and pull that service plug, break that electrical connection so that your battery doesn't continue to degrade.
We had a call yesterday from a gentleman that bought a Tesla Roadster for his campaign trail. He's running for mayor in one of the major cities in the United States. And his goal was to use the Roadster as a poster child for the clean energy initiatives that he's going to enact as mayor.
Okay.
However, he bought the car, put it in storage, it sat for a month, and it got bricked. And that's what happens with a Roadster. If you don't charge it for a month or more, it ends up no longer being able to accept the charge from the charge port door. And by the way, everybody asks this, that is the only Tesla vehicle that has that vulnerability. The rest of them have a design that opens contactors and removes any load from the battery. So the first thing we had him do, or the service center where it's located currently, is remove the service plug, which then takes all of the draining devices off of that battery. And what I mean by that is there's thermal management, there's a pump that continues to run, there are electronics that continue to draw off the battery, and if left in place, it accelerates the demise of that battery to a point where it may not be recoverable. In this case, they successfully pulled the service plug. That battery could literally sit there for 6 months or a year and still be recoverable. And once it gets here, it's going to go on life support. We're going to put it back on the road. And this gentleman is going to be able to run for mayor with that Tesla Roadster as a poster child for clean energy.
That's fantastic.
Well, it looks like we're wrapping up. Do we have anything else that we want to
It's up to you guys. If you guys have more articles, we can keep going. If you guys want to be done, we can be done. We're at an hour.
We're an hour, okay, yeah. I think this is a good time to wrap. As always, we appreciate our audience. We appreciate you guys following our channels, and we enjoy doing these, answering your questions.
We'll be back live on Tuesday.
We will.
Yes, thank you very much for the time. Look us up. We're on YouTube, we're on Facebook, we're on TikTok, we're even on Spotify.
Thank you. We'll see you next Tuesday.